In this installment, we're going to do an introduction to friction. And we consider all our forces, the different types we'll be looking at. We're looking at friction in detail and what it means. What we have depicted here is we have this crate, like so, and I've attached a force sensor to it. It's called a dual range force sensor. And it measures both tensional forces, the kind we pull, and it also can measure compressional forces if we press on something. And basically what we're going to do in this experiment is explore friction by attaching this force sensor to this crate, and I'm gradually going to increase the force I'm applying to it. And eventually it will start to move. And once it's moving, I'm going to try to pull it at constant velocity. And as we collect the data in doing this, this is what we observe. This is the data collected from a real experiment. We're doing that exact same setup. And what we have in our vertical axis is the force, and the x-axis time. So we have force and time. So if we do an Oizerga analysis, the origin isn't quite the origin. If you notice, moving down the vertical, 3, 2, 1, 0 is actually down here. But it's close to the 0. And our horizontal is 0. Y-axis force, x-axis time in normal units. So therefore, anything we know about force or time we'll read off. The slope is delta F over delta T, or the rate of change in force. And the area, interestingly enough, is F delta T, which is the impulse, which we know is also equal to the change in momentum, which is M delta V. But in our study here, we're primarily focused on what's going on with the force. So what happens is we set out and I start applying a force. And the force, I'm just going to put it on the graph like so. I have an applied force. And it doesn't move. I started with 0 force and I'm increasing. And so this force that's resisting me is the force of friction. And you'll notice that they must be equal and opposite because it remains stationary. And in fact, it remains stationary all the way up until I get to here. It's at this point, the maximum force, that it actually starts to move. It accelerates. So what we notice is then, as I am pulling this harder and harder, the force that's being measured is increasing. And we can see the entire time, the force applied and the force of friction are equal to each other.